Next, we're going to work on graphing quadratic equations. Quadratic equations, you have one variable that is squared, and the constant behind it, as you can see here, the letter a, cannot be 0. Because what happens if a is 0? Then that x squared is going to go away, and you're just going to have a regular, everyday, linear equation. So quadratic equations always end up looking like this. So I'm going to draw a tiny little picture here. It's going to look like a U of some sort, or it can look like an upside down U. It's called a parabola. They go on forever in both directions. So as we are looking to graph these equations, we want to make sure that the points that we get lend themselves to creating these U's, or upside down U's. Oh, my arrows don't want to stay. Okay, so we're going to use the same strategy that we used for linear equations. There's a more elegant way that we could graph these, but that's not going to be covered in this course. We're just going to use the t-table. By elegant, I also mean more complicated. So hopefully this will be a happy thing for you. So we're going to have our x's and our y's. This time I'm going to use 5 points to graph this to start off with, just to make sure that we're getting everything in that U. I'm going to have 2 negative points. I'll try -4. Oh, -4 is going to be too big. Let's look at this. We only have up until 7. If we have 4 squared, it's going to be 16. So let's do this. Let's do -2, -1, 0, 1, and 2. Let's just start there and see how it goes. So putting -2 in for x, we have y equals -2 squared. Now that negative is going to be squared, so it's going to come out positive, -1. So y equals 4 minus 1, y equals 3. So we'll put a 3 over here. Now let's do a -1. Y equals -1 squared minus 1. Y equals 1 minus 1, so y equals 0. Put 0 in, we get y equals 0 squared minus 1, so y just equals -1. X equals 1, y equals 1 squared minus 1. 1 squared is 1, so y equals 0. Last one, y equals 2 squared minus 1. Y equals 4 minus 1, so y equals 3. So let's go ahead and plot these points. I'm going to plot them in red because they show up really nice when it's red. So we have x equals -2, y equals 3, x equals -1, y equals 0, x equals 0, y equals -1, x equals 1, y equals 0, x equals 2, y equals 3. So you can kind of see it's going to make that U shape, or that parabola that we were talking about earlier. So let's see if we can draw that parabola. That's no good. And still getting used to this writing tablet. I'm going to connect these guys first. Doesn't want to. Okay. And it kind of loops up here and goes on forever. And this one loops up here and goes on forever. Again, in your assignments, you are going to have a much nicer tool to use so that you can make a nice, smooth parabola that will be its beautiful U shape. Let's go on to another one. This one's a little bit more complicated. We have a middle term here this time. So let's see what we can do. We're going to start with our t-table. We'll start off with our usual 5 points. I'll just start with -2, -1, 0, 1, and 2 again. Those are always nice to work with. So -2, y equals -2 squared minus 6 times -2 plus 8. -2 squared is going to be 4. -6 times -2 is going to be a positive 12. Ooh, this is going to be big. Plus 8. 12 plus 8 is 20, plus 4 is 24. Y equals 24. We're not going to be able to graph that one. That one's too big. Let's look at -1. Minus 6 times -1 plus 8. 1 plus 6 plus 8. This one's still going to be big. Y equals 15. I mean, this one at least we could maybe possibly sort of stay on the page and guess where it is, but it's going to be like way up here. Let's try 0. Hopefully 0 will give us some luck. Y equals 0 minus 6 times 0. I'm sorry, that 0 is squared. Plus 8. So y equals 8. Y equals 8 is still not on this graph, but at least we can kind of guess where it is. Okay, let's look at x equals 1. All right, y equals 1 squared is 1. Minus 6 times 1 is minus 6 plus 8. -6 plus 8 is 2. 2 plus 1 is y equals 3. Oh, finally one that's actually on our graph. Let's take a look at 2. Y equals 2 squared minus 6 times 2 plus 8. Y equals 4 minus what's 6 times 2 is 12 plus 8. 4 plus 8 is 12 minus 12. Y equals 0. So it looks like we're having more luck the larger our x value. So since there are a couple of these that we could not graph, we can't graph that guy, we can't graph that guy, let's do 2 more. Let's add a couple of more x values. And this is just part of the game here. There are going to be times where you have stuff that you just can't put on your graph. So you just have to go with different values. So let's do 3 on this side. Y equals 3 squared minus 6 times 3 plus 8. Y equals 9 minus 6 times 3 is 18 plus 8. Y equals -18 plus 8 is -10 plus 9 is -1. Y equals -1. Let's try 4. Y equals 4 squared minus 6 times 4 plus 8. Y equals 16 minus 6 times 4 is 24 plus 8. 8 plus 16 is 24 minus 24. We get y equals 0. So we can kind of see a pattern here. We have a -1 that's surrounded by 2 zeros. So I'm just going to do one more. just to make sure we're on the right track. I'm going to do 5. And I'm going to guess that 5 is going to give us 3. Five squared minus 6 times 5 plus 8. Y equals 25 minus 30 plus 8. 25 minus 30 is negative 5. Negative 5 plus 8 is 3. And my guess is true. I bet if we did 6, it would be 8. But I'm not going to torture you with that. So let's graph this. So we have x equals 0, y equals 8. That's like somewhere up here. X equals 1, y equals 3, which is about right there. X equals 2, y equals 0. X equals 3, y is negative 1. X equals 4, y is 0 again. X equals 5, and y is 3. So we can use this information to graph. Try really hard to make a semi-oh, not a good parabola, but I'm trying, guys. So there we go, my wavy parabola. Again, yours is going to look a lot nicer. But yes, so this is a really good example of a time where not all of our numbers worked out for us. We just kind of have to go with the flow. All right, this is our last one. And as a reminder, some of these are going to be an upside down U shape, so don't be alarmed if you see that happening. So let's make our t-table. I'm going to go with my usuals. -2, -1, 0, 1, and 2. These are the simplest numbers to plug in, and they can kind of give you a direction on where you should go if they don't work out. So let's plug in -2. Y equals 2 times -2 squared minus 4 times -2 minus 3. -2 squared is positive 4 times 2 is 8. -4 times -2 is 8 minus 3. We have 8 plus 8 is 16 minus 3, y equals 13. That's too big. But at least it's not like way too big like the last one. In the last problem we did that first -2. Let's try -1. Y equals 2 times -1 squared minus 4 times -1 times minus 3. It's a -1, not a 7. All right, y equals -1 squared is 1. 1 times 2 is 2. Plus 4, -4 times -1 is positive 4 minus 3. Oh, this looks like one we can actually use. Y equals 2 plus 4 is 6 minus 3 is 3. Woohoo. Now plugging in our favorite one, 0. 0 is going to get rid of this term. It's going to get rid of this term. And we're going to end up with y equals -3. I love 0. Now let's try 1. Y equals 2 times 1 squared minus 4 times 1 minus 3. So we'll have y equals 1 squared is 1 times 2 is 2 minus 4 minus 3. -4 minus 3 is -7 plus 2. Y equals -5. Let's try 2. Y equals 2 times 2 squared minus 4 times 2 minus 3. Y equals 2 times 2 is 4 times 2 is 8 minus 8 minus 3. Y equals -3. So we can see here we have that same mirror effect right after our -5 this time. We have a 3 and a 3. I bet if we put a 3 in here, we're going to get a positive 3 to come out. Let's try that. You want 5 points that actually work in your graph, and you want to make sure you see that mirror reflection point where the numbers start repeating themselves. So y equals 2 times 3 squared minus 4 times 3 minus 3. Y equals 3 squared is 9 times 2 is 18 minus 12 minus 3. 18 minus 12 is 6 minus 3 is 3. So our mirror reflection is working. This is called our point of inflection. This is where the curve changes. And we want to see that in our graph, so we know exactly how to draw it. So we can't use this one, it's too far out. So we have x is -1, y is 3. X is 0, y is -3. X is 1, y is -5. X is 2, y is -3. And x is 3, y is 3. Beautiful. Now I'm going to make my shaky little thing. So shaky. All right. I'm going to work on making parabolas with my new toy here at some point in the future. But for now, this will work. Your parabolas will not be this shaky, but you should have a nice U shape. It's actually kind of narrow. It's kind of becoming a V shape, but they'll always actually be in the shape of a U. It will never be a straight up V. So go ahead and try to work on problem 10 on your own. If your parabolas are as shaky as mine, you may want to consult a physician, or you may be having troubles with your drawing tablet as well. Otherwise, I will see you in the next video.